Hello everyone and welcome to another mini lesson about basic concepts of chemistry. Today we're gonna integrate the knowledge that we have from the previous 3 lessons into some calculations, okay? So we're gonna start with a simple chemical reaction. Methane reacts with oxygen to produce carbon dioxide and water, okay? I will balance this chemical reaction simply adding 2 coefficients, one here and one here, and now the reaction is perfectly balanced. You can check how to balance chemical reaction in previous mini lessons. Okay, so now let's say I want to calculate how many grams of CO2 are going to be produced when I burn, let's say, I'm just making this up, 600 grams of methane, okay? So the way that we can use this balanced chemical reaction is like a recipe, okay? Remember, let's say a recipe for baking a cake. You need 5 eggs, and you need to combine them with 1 kilogram of flour to produce 1 cake or 2 cakes, I don't know. So think about a chemical reaction also as a recipe to produce these products. So you need to combine 1 molecule of methane with 2 molecules of oxygen to produce 1 molecule of CO2 and 2 molecules of water. You can also look at this coefficient as moles, okay? So 1 mole of methane has to react with 2 moles of oxygen to produce 1 mole of CO2 and 2 moles of water, okay? So we need to speak the language of the moles so we can use the recipe to calculate things, okay? So we saw in the previous video how to convert, or we saw the concept of molar mass, and I mentioned that it's useful to convert grams of any substance into moles of that substance. So we want to do that because if we convert these 600 grams of CO2 into moles, then we can apply the recipe, which is the balanced chemical reaction, to calculate the moles of product that we can obtain. And then again, using the molar mass, but now of CO2, we can convert those moles into grams of CO2, which is what I want to know. So super easy. You just take your 600 grams of methane, and you will have to put here in these parentheses the molar mass of methane, okay? So how do we calculate the molar mass? Remember that you can find that information in the periodic table. You will find that carbon has an atomic weight or an atomic mass of 12. We have only 1 carbon atom in this molecule, so we just multiply it by 1. And the mass of hydrogen, you will find it around around the value of 1 or 1.008, but in this case, we're gonna round it down. So 1 is the mass or the atomic weight of hydrogen. I multiply it by 4 because in the methane formula, I have 4. So that is a 4. If we add the 12 and the 4, we get 16. So 16 grams per 1 mole is the molar mass of methane, okay? So we can write this in this way inside the parentheses. We can say 1 mole of methane weighs exactly, or not exactly, but around 16 grams, okay? So I put it this way because in that way, when I do the multiplication of this number by this fraction, you cancel out the grams, okay? And you end up with the moles of methane. So that's how you use the molar mass to convert from grams to moles, okay? So if I do this calculation, I'm gonna use my calculator, divided by 16. I have it's 37.5 moles of methane, okay? So I just took the grams of a reactant, I calculated the molar mass of that substance, and I used that to convert the grams of the substance into moles of substance. Remember, we want this because our recipe or our balanced chemical reaction, it's written in the mole language, okay? So now that I know the moles of reactant, in this type of exercises or calculations, we assume that the amount of oxygen is enough. We have enough oxygen to convert all of the moles of methane, okay, into product. So the rule says that for each mole of methane, you produce 1 mole of CO2. So the conversion is pretty straightforward, okay? So if I have 1 mole, I produce 1 mole. So if I have 37.5 moles of methane, I will definitely produce 37.5 moles, but of the product of CO2, okay? This is not always the case when the relationship is 1-to-1. For example, if I wanted to calculate the amount of water that is produced when I burn 1 mole of methane, I will have to multiply the moles of methane by 2, because for each mole of methane, I produce the double number of moles of water, right? So the relationship is 1-to-2. So in this case, I just had to multiply by 1, but it can be the case that you have to multiply by 3, or you even have to divide by 3. Let's say that the reaction says that you need to burn 3 moles of methane to produce 1 mole of CO2. It's just an example. You will have to divide your moles by 3, okay? It's as simple as that, okay? So now that I have the moles of product that I obtained when I burned 37.5 moles of methane, I just have to convert these moles of CO2 into grams of CO2. So I basically do the same with the molar mass, but I use the inverted version, right? But first I need to calculate the molar mass of CO2, okay? So we go to the periodic table, we find out that 12 is the atomic weight of carbon. I multiply that by 1 because I just have 1 carbon atom in the formula, okay? And the mass of oxygen is around 16, and I have to multiply it by 2 because I have 2 oxygen atoms in the formula of CO2. So 12 times 1 is 12, 16 times 2 is 32. And if I add those two numbers, I have 44. So the molar mass of CO2 is 44 grams per 1 mole, okay? So I'm gonna use that molar mass to convert from moles of CO2 into grams of CO2. So I'm gonna do that down here, 37.5 moles of CO2. Then you open your parentheses, you put here your molar mass. I'm gonna use it as we wrote it here because this is the way we can cancel out the moles, okay? 44 grams are equivalent to 1 mole of CO2, okay? In that way, I can cancel moles and moles when I multiply the 37.5 by 44 grams. So I'm going to write the answer down here. I'm going to use my calculator. So the answer is 1,650 grams of CO2. Okay, so now I have the answer that I wanted. I wanted to calculate the grams of CO2 that are produced when I burn 600 grams of methane. Okay, I'm just gonna check that again because, yeah, correct. 1,650 grams of CO2, okay? So in summary, we converted, I'm gonna write the basic idea of, sorry. I'm gonna write the basic idea of what we did down here, okay? So we basically took the moles of substrate and we converted them, sorry, we started with the grams of the substrate, the reactant, sorry, I'm an enzymologist, so I'm used to talking about substrates, but yeah, they are the reactants. So we took a certain amount of grams of the reactant, okay, and we converted to moles of that reactant. For that, we use the molar mass of that specific reactant. Then we use the stoichiometric relationship or the molar relationship between the reactant that we're using and the product that we are interested in. And we convert that to moles of product. Then we use, again, the molar mass, but now the molar mass of the product, okay, to convert it to certain number of grams of product. Okay, so we basically do that trip from grams of reactant to grams of product. Okay, we can do the same backwards. Okay, we can start with certain amount of product that we want to produce, and we just have to move in the opposite direction. Okay, and we can calculate then the grams of reactant that are needed to produce that amount of product that we want. Okay, so give it a try. Try to make some problems, some calculations with your own chemical reactions, and let me know how it went. Thank you very much, and see you in the next video.